morning. Should be able to hear me and should see the desktop by now. Does everything seem okay?
Yeah, looks good.
Okay, great. Okay. All right. I remember I finished grading the exams the other evening. So your exam score you should be able to see it on Brightspace. So look at your exam score, and more importantly, like I said the other day, look at your exam itself. Make sure that you look at the problems, how they were graded, and if you have questions about how they were graded or how you're supposed to do them, or if you have questions about anything I wrote on the exam, please send me an email or come by office hours. Okay. So any kind of question at all. We're not going to go over the exam in class, okay? Because everybody could end up with different questions. Some people have a question about one problem, so you have a question about another problem. It's a lot more efficient for you to ask specifically about your exam. So we won't go over it in class. So if you have any kind of question at all, please come and please send me an email about it, or come to office hours and ask about it. Okay. Okay. So today we're going to pick up where we left off yesterday with nested for loops. Now there's one more reading assignment about loops, and then there's some problems in this online book about a bunch of mixed up code problems involving loop that are nice problems. And then on this other page, there's a lot of problems. Okay, there's I think 17 or 18 problems on this page. So I asked you, they're all good practice problems, and practicing programming is the way you learn. You have to do programming to be able to learn it. So on here I asked you to do 8, 12, 13, and 16 at least. I think those were nice ones. And they kind of goofed up the numbering. Notice that every problem has two numbers, 4.8 point, and then it's got a different number over here, and then it's got one number here and a different number over here. So I'm using these activity numbers. Okay, so I said to do number 8. So that's this one here. This one's 8. Section 4.8, number 8. Okay, they're nice. They're nice little problems, and you can solve them. They're a lot like coding bat. You solve them here. You solve them right here, and when you run it, it'll tell you whether you did it right or not. Like when you run it, you get a report. See, I didn't do very well. So I failed all their tests, but you get a report here of how well you did. So you can you get a sense of whether you're doing it right or wrong by practicing this way. Very much like coding bat. Not quite as nice as coding bat, but very much like that. Okay. All right. So do these, practice doing loops. There's a chance to get some practice with doing loops. Okay. Now here's the last example we did in class. Yeah. Now, the example printed out this pattern here. Okay. So I want to see, let's try other patterns. Let's in the code, it showed like some other examples. Like, what if I want to do it this way? That was descending. See, this is getting longer. These are getting shorter. Okay. These other ones, and like this is the one we just did the ones where they're getting this is the one we did. This one does this. This one, they get shorter. This one's kind of odd. The triangle's off to the side. That one's a little bit harder. Okay. So now let's go ahead. Let's try to do this one. So let's go. What we're going to do is change this to be, instead of it being this one here, let's make it for now this one. Okay. So let's do this, a descending. Like right now, if we run it, okay, it grows from 1 to 1, 2, 3, 4, 5, 6, but we want it to shrink from 1, 2, 3, 4, 5, 6 down to 1. Okay. So now we have 6 rows. So we have this number. Oh, let me try to say, what happens if I, what if I change that number to say 10? Notice it grew up. It had 10 rows now, and it grew up to 10. Though, once you get to two-digit numbers, it kind of messes up the pattern. So the pattern doesn't work after 9. You get this staircase, but then all of a sudden, it goes up by 2 because this last number here is a two-digit number. So it works best if we keep that number of rows below a single-digit number. And I can go over here and make this 3. So we have a parameter in this program. See, so I can make this just 3, and I'll get 3 steps. And it's important, this idea of a parameter is important. We want to keep track of the fact that our program can be changed. Like that could end up being a method parameter. We'll go back to methods later on. And for example, this is almost like a method where there's this input parameter that tells the program what to do. It tells it to do a certain kind of output. Okay, in this case, it said how many rows are in the output and how long the bottom row is. Okay, so now let's change it to be this pattern here, where the pattern will start with parameter 6. Okay, now the outer loop is saying what row you're in, and we're always going to have to start with row 1, row 2, row 3, row 4, row 5, row 6. So there's row 1. Then in row 1, this one does row 1. The for loop goes across, and then this one at the end takes you back to the beginning of the next line. Okay, so this is the one that goes across the row. Okay. Okay. Now, in the other picture, actually, I'm going to go back to it. We were doing this one. Okay. In this picture, in row 1, we wanted the row to have length 1. In row 2, we wanted the row to have length 2. In row 3, we wanted the row to have length 3. Okay. Now in this one, we want in row 1, remember, see, we're counting from 1 up to rows. In row 1, we want the length to be 6. And in row 2, we want the length to be 5. We want to count down. Okay. There's a couple ways we could count down. Okay. Well, we actually see, well, okay, well, in row 1, we want the thing to have length 6. And in row 2, we want the length to be 1 less than that. Okay, so in row 1, we want the length to be 6, which is actually what rows is. Okay, now that's in row 1. In row 2, we want this to be 6 minus 1. And in row, so this is, the length of this is 6. The one here, the length is 6 minus 1. Now this one is 6 minus 2. This one has length 6 minus 3. Okay. Now this is row 1. This is minus 0. Row 2, this is minus 1. Row 3, this is minus 2. So it's 6 minus the number of rows minus I minus 1. Okay. Notice I kind of by making a little table down here. And this is going to be a trick we're going to see pretty often. To get these patterns, a lot of times you have to write a little bit of information next to the pattern to see what the pattern is. Okay. In row 1, so I can actually make this into a table. Here's how in row 1. I'm going to make a table with a row column and a column. Okay. In row 1, actually, this is, I'll give it a different name. This is the I column. This is what I is. In the I column, I'm in, and then over here, I want to know what is the length. Okay. what's the length for the j? Okay, when I is 1, when I is 2, when I is 3, when I is 4, when I is 5, okay, the length is 6. That's 6 minus 0. The length is 5. That's 6 minus 1. The length is 4. That's 6 minus 2. Okay, but in fact, okay, but 6 minus 0 equals 6 minus, well, 0 is I minus 1. Okay, and here the length is 6 minus 1, but that's really 6 minus 1 is I minus 1. Okay, notice now I'm seeing that what the pattern really is. The length is always 6 minus I minus 1. Okay, here I'm in row 3. I want this to be 6 minus 2. That's 4. And 2 is 3 minus 1. Okay, so that's the, and 6 is rows, so there's what I put up there. See, I derived a little formula. This is the real trick. This is real common in these kind of problems, and it's real common in lots. We use these little patterns as to showing you tricks that get used pretty often in writing programs. Okay, you need to do some kind of pattern. It doesn't have to be a visual pattern. A lot of times the patterns are more abstract, but there is some kind of pattern, and it's going to be done by loops. And if you think of what your pattern is doing and you make like a little table, you can see what the code would be. Okay. Now what do? I print out, okay, now J is going to go from 1 up to, oh, let's see. Oh, I wrote that in the wrong place, didn't I? Ah, I was writing that in the wrong place. That goes down here. Okay, this is just rows up here. Okay, this thing counts the rows, and then this thing counts the columns. So I was typing this little formula in the wrong place. Okay, so this is how long the ith row is. So how long is the ith row? It's 1, 2, 3, 4, 5. Okay, so that's rows minus I minus 1. That's how long a row is. Then what do? I count up from 1 to the length of the row. So I don't change this. I'm going to count up from 1 to the length of the row, the total length of the row. Okay, okay. And okay. So let's just see what it looks like now. Okay, so we've got the picture we wanted. Okay, and if I change the parameter, I mean, 6 here really wasn't what I was working with. I'm working with rows. I'm really working with this number, rows minus that. Rows minus that. Okay, so if I change this number to be, for example, 9, I'm going to get, well, I'm going to, now this picture here will no longer be an accurate picture. Notice that this picture here was only when rows with 6, but it still told me how to write the code. It gave me a sense of what the pattern was. When I will go up to that number there, then I go up to that number less than 1. That's this number here was this number here. Okay, so if I visualize it with rows 9, go to the end, you can say, see, I got this staircase going down from 9 to 1. Okay, all right. Okay, so that was a little bit trickier. Now there's several ways to do this problem. Like, let me copy and paste this into another window and show you a slightly different way of doing the same thing. Okay, so open the Java visualizer. Now here, see, I have this kind of funny, goofy I minus 1. Okay, I can make that nicer by going here and saying, instead of starting my row counter at 1 and going up to less than or equal to rows, I can shift this all down and I can say I goes 0, 1, 2, 3, 4, 5. I can make I go from 0 to 1 less than the number of rows. And then, oh, then look, see, this is 6 minus 0, 6 minus 1, 6 minus 2, 6 minus 3. And I can just change this one over here, simplify this one to 6 minus I. Okay. I can shift, and sometimes this is a nice way to make code work better, not work better, it works the same, but sometimes this is a nice way to make code simpler. You could shift one of the indexes. Here I shifted it from, instead of being from 1 to 5, from 1 to 6, I shifted it from 1 to 6 to 0 to 5. Okay. From 1 to 6 to 0 to 5. From 1 to 6, 0 to 5, and then I get a simpler code. I just need this, rows minus I, rows minus I. This is 6 minus 3 is rows minus 3, because I'm in row 3. Okay, so counting from 0 up to 5, see, if I let I count up from 0 to 5, instead of counting up from 1 to 6, I end up with a slightly easier thing to put right there. Okay, let's just check. It's going to give us the same picture. See, now there it was with 9. Okay, so, and if I go back and change it to 6, be like what we started with. Now the picture will match the picture. The picture here will match the little table I made. I made the table with one example of what rows could be, but then I wrote the code in terms of the general one. Okay, so I get the right output here for that value of rows. Notice that it's kind of, this is what the picture looks like when rows is 6, when you make rows 6. But we really want to be able to make the code work right when there's any value for 6. And in this case, the pattern clearly holds. The pattern doesn't change when I change this value here. This doesn't work if somebody gives you a pattern somehow where the pattern is different when you have when the number of rows is, if the shape of the pattern should change when the number of rows changes, then you can't do problems like that this way. In a problem like this, you're assuming that when you change this, the way the pattern works in this picture doesn't change. Okay, so you draw the pattern in one size, and then you figure out how it's working in terms of that size variable. Like, it would be wrong here. Here's what would go wrong here if I just put 6 here and 6 here. Okay, okay, do that. Visualize execution. Sure looks okay to me now. Okay, go up here, try size 9. Go down here. It's not size 9 because I didn't use this variable. Okay, oh, so I need to change it there. So rows. So I check now. Okay. Oh, no, it didn't work. See, I said rows is 9, but I didn't get 9 rows. Okay, because I didn't notice what I did now is I goofed up. I have a mixture of, this one's used in terms of rows, this one's got the 6 in it. See, now you got to be real careful when you do these things. See, here I used the rows variable, but here I didn't use the rows variable. Like, here's another example. If I put rows there and leave 6 there, and look at the picture, it gets chopped off. See, it only did 1, 2, 3, 4, 5, 6 rows because it's got only 6 rows. I didn't use that variable there, and so I don't get the right picture over here. So I need to make sure my code uses this variable where it should be. Okay, so there were that many rows. Okay, so in the first loop, there's that many rows. This is how many rows there are. And I'm numbering the rows from 0 up to rows minus 1. And then down here, I'm saying, my little table says that how long the row is, which is this thing here, how long each row is rows minus I. Okay, rows minus I. Okay, so then I put that formula there. Notice I don't want it to be 6. I want to get, here I see it's 6 minus 0, 6 minus 1, 6 minus 2, 6 minus 3. But then you need to know that that's really rows minus 1, number of rows minus 2, the number of rows minus 2, the number of rows minus 3. Okay, I need to realize that part, the table doesn't tell you to do that. If you just put this here, you could just end up with 6 minus 0, 6 minus 1, 6 minus 2, 6 minus 3, and you might think that this should be 6 minus I. But then it would only work with one parameter. It wouldn't work with this thing here. Okay, so we want that thing to be rows. Okay, all right. Now let's try another. Remember, if we go back over here, we had another pattern that would look like this. Okay, right? So let's try to do this one. Let me open up another Java Visualizer window. And let's see if we can do that harder pattern. So what we want now is this one. Okay. The reason this is going to be harder is that we need 3 loops now. Okay. We need a loop that tells us to do that row, then a loop that does that row, then a loop, we need a loop that does the rows. Well, that's still going to be this one, okay, that does that many rows. But then in a row, we're going to make a little table. We need to count how many spaces there are, okay, and then how many numbers there are in that row. For example, in this first row, I've got 1, 2, 3, 4, 5 spaces. So in the first row, I have 5 spaces. Then in the next one, well, they keep shrinking. So the next one, it's 4 spaces, then 3 spaces. So it goes down, it's 4 spaces, then 3 spaces. I'll just keep writing it out because what we really need to do is figure out what the pattern is. 1 space. Notice at the end, there's 0 spaces. Okay. And then after the spaces, there's 1 number, then there's 2 numbers, then there's 3 numbers, 4, 5, and 6. Okay. And the numbers start with, and what do the numbers start with? The numbers start with, we're making a little table of the information, and we're going to have to write a formula that uses all this information. So it starts with 6, and this one starts with 5, counts up to 6. This one starts with 4. So after the spaces, after 3 spaces, there's 3 numbers that start counting at 4. Okay. And then the next row, there's 2 spaces. And after the 2 spaces, there's 4 numbers that start counting up from 3. And you start counting up from 2 here, and you start counting up from 1 here. Okay. And then what row are we in? There's more information. Well, now the row, this is the I counter. We could make this row 0, row 1, row 2, or we could actually, it's going to be up to us to decide whether or we can make it I starts at row 1, row 2, row 3. Now this is an or. We can either do it one way or the other. We can do one or the other. Remember in the last example, we saw that if we made the row I start at 1, we got a little bit messier a formula. if we made I start at 0, we got a little bit simpler a formula. Okay, so we saw it kind of matters. You could say it doesn't matter because you get the same output. The code works the same, but this one's a little easier to read, and a little easier to read is a good thing. Okay, so the fact that this one's a little easier to read means it was probably a better idea to make I start at 0. But people argue some of this is a matter of style. Okay, somebody might like this one better. They don't mind this part here, but they think row 1 makes more sense to them. Row 1 through row 6. Another person might say, oh, I don't mind counting from 0. Row 0 up through row 5 is fine with me, and I get a slightly simpler formula here. So, do you mind having a row? Do you want it to be row 1 through 6, or do you mind? Is it okay with you to have row I 0 through 5? Do you not mind this little I minus 1 here? Okay. So you get, in this case, that was the right way to do it. And this one, I think either one of these is right. And I kind of think this one's a little bit better. Okay. Over here, I'm not sure which one of these is going to be better. Should it be 0, 1, 2, 3? Yeah, and this one counts from starting at 1. So which one of these is going to give us a better answer? This would be 4. This would be 5. Now I'm writing it all out so we can just kind of see it. We don't, sometimes you can do these problems without this much detail, but right now I'm just doing it with lots of detail so that we could kind of see what's going on. Okay, all right. Now, what I need is 2 loops. Inside this loop, I need one loop that's going to do this part. That's why I need these columns, because I need 2 loops. One loop, so I'm going to go here and I'm going to say I need one loop. So for blah, 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 this loop will do the spaces because the spaces come first. Then in that row, after you do the spaces, you'll do the numbers. See, this is a trickier problem because we need 2 loops. One that'll count the spaces, then one that'll count the numbers, and then terminate the row by going to the beginning of the next line. Okay. I can use my variable j here because this j lives in this loop and this j lives in this loop, so I can reuse the letter j. So I have j equal to something. I need a start value for j. Don't assume the start value is 1. In fact, we're going to, down here, we may need to change these. I need a start value, a stop value, and, well, okay, increment's probably going to be by 1. Everything's changing by 1 here. Okay, here I need j, a start value, j less than or equal to a stop value. And remember, I can choose to make it either less than or equal to or strictly less than, whichever one maybe makes it easier for me to think about the code. So even here, this could stop, I could have the stop condition be a strictly less than, okay? And then I'll need an increment here. Okay, now I use my table to figure out where do I start, where do I end? Where do I start? Where do I end? But I use I as my information. Now, again, I can be either starting at 0 or starting at 1. Okay, right now I've got it. Right now we're in this version here. I'm starting with, up here I'm saying I equals 1 up to rows. Okay, so let's see how it works with this choice of I. Okay, how many spaces are there? Okay, this is, well, that 5 is really rows minus 1 in this case. So the number of spaces is rows minus 1. Rows minus, okay, now rows minus 1, if we stick with this, there's I. So there's rows minus I. Rows minus I. Rows minus I. Okay, so the number of spaces is rows minus I. If we stick with the I starting with 1 column, so let's stick with that. So then and where do I start with? Okay, that would mean I start with 1 here. So start counting from 1. up to rows minus I. Okay, so start count from 1 up to rows minus I. Okay, count from 1 up to rows minus I. Oh, and then I print space. See, now I need to put something in the body there. I print a space. Okay, so I'm printing that many spaces. Okay, notice I can't use a string because the number of space, I can only print one space at a time because every time each row has a different number of spaces. So there's no, like I can't put a 1, 2, 3, 4, 5, 6 space string there somehow because the string keeps changing. So I'm using a for loop to build up that string. See, essentially what I'm doing is I'm using this little loop here to build up that many spaces. So I print one space at a time. So print one space. Okay. Now go to the numbers part. Okay. Okay. There's one number. Okay. Like look here. We're in row 3. We want to start with. See now here. Look. See now here. We need a different start value. The numbers start with row plus 1. See if I go across in here. The numbers start with row plus 1. The numbers start, no, that wasn't right. Now see if I go, no, the numbers start with, see, yeah, it's a little bit tricky here. See, I started with 6. I'm sorry. This one starts with 6 and ends with 6. This one starts with 5 and ends with 6. So I want to know what the start number is here. Okay. I start with 5 when I'm in row 2. I start with 4 when I'm in row 3. I start with 3 when I'm in row 4. Okay. Now, if you switch this other I column, maybe it's a little bit easier. Okay. In row 1, in row 0, I start with 6. In row 1, I start with 5. In row 2, I start with 4. Well, that's row minus 2. And in row 3, I start with row 6 minus 3. In row 4, I start with 6 minus 4. And in row 5, I start with 6 minus 5. You notice if I use this column, it's a little bit easier to think about this one. Okay, so I'm gonna, so let's switch. But then if I decide to use this column here, I have to go back to the spaces and ask, what's true about spaces here. Okay, if I go back to this column here, this was 5 spaces. Okay, that's not rows minus I. Now that's rows minus I plus 1. Okay, and this is how many spaces that are here. Now this one's trickier. The number of spaces is rows minus I plus 1. Now notice that either way, it's a little bit tricky. This I version of I worked better for one of these loops, and this version of I worked better for the other loop. But you can't, the two loops have to have the same I. You either have to pick this one or this one. Okay, let's stick with, well, we already used this one, so let's stick with it. Okay, let's stick with this one. It's going to be a little bit trickier. Okay, what's our starting number? Okay, it's going to be rows minus I plus 1. Okay, it's going to be rows, okay, minus something. We started with 6. We start with 5. We start with 4. Starting with 6 is rows minus 0. Okay, rows minus 0, but I is 1. So that's I minus 1. Okay, okay, and check, like take row 4. When I is 4, we're supposed to start with 3. Okay, are we starting with the right thing? 6 minus 3 minus 1 is 2. 6 minus 2 is 4. Oh, no, let's see. Okay, when I is 4, 4 minus 1 is 3. 6 minus 3 is 3. See? Try this row here. When I is 5, 5 minus 1 is 4, 6 minus 4 is 2, we're starting at the right place, okay? Now, where do we stop? The numbers always stop with 6. See, we count up from that starting number up to 6. So we always count up to rows. Now, notice how many times rows is appearing now. Rows is there, rows is there, rows is there, rows is there. Notice that that variable is appearing in quite a few places. I think I'm done, okay? Oh, and I want to count, and I'm printing J. J goes from 4 to 6. J goes from 3 to 6. J goes from 2 to 6. Okay, so I think I got this ready. Let's just try it. Okay, go to the end just to see. Oh, looks good. Okay, there's that. Okay, let's try another input. Let's try starting with 9. Check. Okay, there's a. These are really challenging problems. We're going to keep doing patterns, like we're going to do patterns. We think of these as patterns, where you want to write code to draw a pattern. And the pattern will always have some size variable in it. So instead of saying draw this picture, it's really draw the picture that has this pattern to it. Where if you change the size, you'll get the same pattern. See, you get the same pattern, but with different sizes. Now, this pattern only works up to 9. It only works for, let's see, what if I do it with 1? With the pattern, what should the answer be when I put a 1 there? Well, I think it died. Oh, let's see. When it dies like that, the safest thing to do is copy all your code. Make sure you copy all the code. Copy it, then reload the page. I mean, you could just try. Well, see, this button's grayed out, so it's really kind of lost. So, when it does this, copy all the code and reload the page. When you reload the page, you lose your code, and that's why you copy it so you can put it back in, and then just see if it there. Okay, see, glitch in their server. Okay, and then look at the picture. Oh, well, okay. When the pattern would just be the number 1. Okay, the pattern. If you if you're not sure about that, you think about it. The when we did a 3, you did space 3 space 2 3 1 2 3. Okay, that's the pattern for size 3. What's the pattern for size 2? The pattern for size 2 would be space 2 1 2. Now make the pattern even smaller again. Size 1, the pattern would be 1. One row with just number 1 with 0 spaces in front of it. See, this had 1 space in front of the 2. This had 2 spaces in front of the 3. So this would have 0 spaces in front of the 1. So that's how the pattern shrinks to that. That's the smallest size for the pattern. And that's what we got. Okay. Okay. Now, you could, if now we did this one using that choice of the right hand column. Okay, we used that choice of the right hand column. So if I want, I can clean this up by saying what I used was that choice. So I used this guy for the I. So I'll clean up columns so that it's not confusing. If I leave it, if I leave in the choice, but I made the choice, it's confusing for people if they want to read this. So here's the choice I made for I. I starts from 1. So I chose to use it with I starting from 1. Okay. Well, I goes from 1 to number of rows. Okay. All right. Now I could go change this code the other way. It'll change a little bit. It won't be easier. It won't, this case, the 2 different choices for I, whether you started at 1 or the other choice where you started I at 0, that choice it's not going to make things any easier. So the choice I didn't make, starting with 0, it doesn't make things any better. Okay, so yeah, you could try it as an exercise. Try shifting. See, that would make this guy go from 0, strictly less than rows. That would be the other choice. But then you're gonna have to make little changes everywhere around here. You'll need to make little changes. Okay, so let's keep it like this for now because it works. Let's try another example. Okay, um, let's see. What would be? Let's see. I'm trying to remember. Oh, the next example. Okay, let me copy and paste this. The next example is this one turned upside down. Okay, so the next example would be count up. It's um, look like this. There, count up. Okay, I still have this. I still need these leading spaces. Okay, but I want this. Do it this way. So the leading spaces are instead of starting with lots of spaces and the space is shrinking, now start with no spaces and the spaces are growing. Okay, so the number of spaces is 0 here now, and 1, 2, 3, 4, up to 5. There are 6 numbers, 5 numbers, 4 numbers, 3 numbers, 2 numbers, 1 number. The numbers start with 1, numbers start with 2, numbers start with 3, numbers start with 4, 5, and 6. And then I have to decide what my row counter should be. Should this be row 1 or row 0? Should I start with row 1 or should I start with row 0? Okay. Well, let's keep it this way. Let's see if it works out nicely that way. Maybe we'll want to switch to this one, but let's start with this one. Okay. Now I need the same structure of a program here. I need the outer loop, and then I need 2 inner loops. The first one will do the spaces, the next one will do the numbers. But I don't know what the starting number is here, so I'm going to put blanks where I have to choose things now. Okay, I have to choose that guy, down here, need to choose what the starting point is here and what the ending number is here. So I've got 4 choices to make. What does this one start at and end at with the spaces? What does this start at and end at with the spaces? Okay. All right. When I is, notice that when I is 1, I have 0 spaces. When I is 2, I have 1 space. Okay. No, so right now this number of spaces is I minus 1. If I use this I, then the number of spaces is I. Okay. So far it's not hard either way. So the number of spaces will be, I'll count up from 1 to I minus 1. See? So I'll go ahead and do it this way. Okay. I'm going to start with I as 1. So I'm in row 1, and the number of spaces goes from 1 up to I minus 1. Okay. Now notice that if in the first one, when I is 1, there should be 0 spaces. So I'm going to count from 1 up to 0. That won't work. You can't see that loop won't print any spaces because J will start at 1 and 1 won't be less than or equal to 0. So it won't do any spaces. That's kind of tricky. yeah, the loop is there, but it won't loop. So you notice that the first loop is supposed to put the spaces, but on the very first row, there are no spaces, so that loop shouldn't do anything for that one case. That's the case when I is 1, and you can check. When I is 1, J will start at 1, then J will go up to 1 minus 1 is 0. Well, if you start counting at 1, you're already beyond the stopping point, so this loop won't do anything. So it gets skipped over. Okay. All right. Now, what about the numbers? So that should work for the spaces part. What about the numbers part? Well, I start with number 1 here, start with number 2 here. So in row 1, I start with 1. In row 2, I start with 2. In row 3, I start with 3. Well, luckily, that's kind of nice. I start with what row I'm in, I. Okay. And then what do I go up to? Well, I go up to I go up to 6, which is rows. How many rows? Okay. So this one turned out to be pretty straightforward. Okay. If I do my I counter this way, this one's pretty straightforward. I need an I minus 1 here, but then I just go from I up to rows here. 1 through 6, 2 through 6, 3 through 6, 4 through 6. Okay. So I think that should work. Let's try it out. Look at the picture. Whoops. What happened? Oh, I forgot to change this guy. See, I forgot to change him back up to put him at 6. Okay. There, 1, 2. So there's the picture we wanted. Okay. And what about if I try a different parameter? Okay. If I try 9 up here. Okay. Work fine. Okay. Notice if I put something like 20 up here, it's not going to work fine. It'll do what we tell it to do, but because some numbers are 2-digit, oh, it didn't actually. That was too many steps. But see, because things start becoming 2-digit numbers, it just doesn't look right at all. Okay. So it only works when you're doing something with single-digit numbers. These patterns are now. Let me. I can actually change something in this. Instead of printing numbers, why don't I just print out a star? So what if I just make this here? Maybe actually like simplify the problem a little bit. What if I make this 1, 2, 3, 4, 5, 6 stars? 1, 2, 3, 4, 5 stars. 1, 2, 3 stars. Oops. Oh, 4 stars. 3 stars. 2 stars. 1 star. Now, to change that, instead of printing J, I print star. Okay. Oh, now my 20 makes sense. Except that it's going to be a slightly too big a loop for the visualizer. See, the visualizer is not letting me do a loop that's that big. I could, if I want to see it, let's go where there's no restriction. So take this and let's go to the Dr. Java. There. Oh, Dr. Java started up in the goofy way. So quit Dr. Java and start it up again. Seems like a lot. Very often, the first time I start it, it starts up kind of messed up like that. I think I mentioned a long time ago, Dr. Java was written long before Windows 10 came around, and it seems like it needs to be rewritten. It didn't have any of these problems in the older versions of Windows. These problems with Dr. Java crept up in Windows 10. The code for Dr. Java is just getting probably a little bit too old. Okay. All right. Now, there's our code in Dr. Java. Now, Dr. Java won't have any restriction on on size of output. So I need to save this on my desktop. So I'll save it on the desktop. Okay, and compile it. Okay, and run it. Okay, and there's my picture of a, see, it worked. With stars, I can make the patterns as big as I want. Okay, so with stars, if I want to make like I can do a size 50 pattern, need to recompile it, run it. Now, even Dr. Java is not going to have has a little bit of trouble with a pattern that big because it doesn't quite fit in its window. So you have to kind of scroll the pattern, but you can draw some really nice. We'll draw some interesting patterns this way. We're going to keep doing more elaborate pieces of geometry, and we can draw some kind of neat things this way. So Dr. Java doesn't have a restriction on size. Okay. All right. So if we go away now here, the thing about the advantage of doing it with numbers is the numbers made it easier to see what we're doing. We started with this. Here, it's up to you to keep track of what this thing starts at. Sometimes these numbers here make it a little bit easier for people to think about what it's doing, how like it's counting down this way. Okay, and also let me take this one and do another version of it again. I'm gonna keep that pattern more or less the way it is. I'm gonna make a slight change in it. Okay. I want this shape here, but I want to start here with 1 and make that 1, 2, 3, 4, 5. And then I want this one to start with 1 and make that 1, 2, 3, 4. And I want this one to start with 1 and make that 1, 2, 3. And I want this one to start with 1, so make that 1, 2, and make that 1. Okay, just a little bit different. And it's still got the same shape. Notice I got 1s on the diagonal. Okay, all right. So let's change it to make this pattern with numbers. Now I have to stick. If I use numbers, I have to keep the rows less than 9. Okay, so I'll go back here to 6. But with numbers, I can do kind of neat things. I can keep that shape, but I can switch you from counting from 1 up to 6. I can, instead of stopping at 6 like the previous version did, instead of always stopping at 6, now I'm saying always start with 1. So I'm saying always start with 1 here. Okay, so I start with 1. I start with 1. I start with 1. I start with 1, I start with 1, and I start with 1. Okay, I always start with 1. So that doesn't become important anymore. What becomes important now is how many numbers there are. I'm going to start from 1 and I want 6 numbers. I'm going to start from 1 and I want 5 numbers. I'm going to start from 1 and I want up to. So this is actually what number I stop with. So this one here is, see, I stopped at 6. I stopped at 5. I stopped at 4. So this column becomes kind of superfluous, and this column tells me where I stop at. Okay. Okay. So in a sense, this is the stop number. But remember, now these loops are start and stop. Okay. So I start with 1 and I stop at 6. I start at 1 and stop at 5. Well, that would be what's going on in this loop here through the numbers. I start with 1. I always start with 1, and I stop at, well, this is 6, which is rows minus 0. This is 5, which is rows minus 1. This is, okay, so this is if I count this way, this is rows minus I minus 1. Rows minus I minus 1. Rows minus I minus 1. Okay, so where I stop is at rows minus I minus 1. Now, if I'd have made the I counter different here, it may have made it easier. Okay. If here I'm still using the I starts at 1. I could shift this one to the I starts at 0. You can try that, but let's stick with this one. So the stop number is rows minus, so the stop number is shrinking, but what is, it's the I minus 1. So 6 minus 0, 5 minus 1, so that's I minus 1. 6 minus 2, so that's I minus, I is 3, 3 minus 1 is 2. Okay, so that should be the rows part. Now the spaces part won't change because it hasn't, it's still the same shape. So I don't need to change, I don't want to change the spaces part. I'm changing the counting part. Okay, and I should get this one now. So visualize it, see if it works. Oh, and then I need to go and put back. Now, what am I printing? I gotta make sure. I'm printing out, well, J is the thing that counts from 1 up. So this is just J. Okay, so I'm printing J. J counts from 1 up to 6. J counts from 1 up to 5. J counts from 1 up to here. So I'm printing J. Oh, what did I do wrong? This is kind of a good, what did I do wrong here? I'm printing J. This is J as a string, and really I want the number that J holds. So I need to get rid of the little quotes there. So now print J as the, see, remember, that's actually a real easy mistake to make. That's J as the letter J. I want the value in J printed out. So when you say print J, that's, if you say to somebody, oh, you need to print J, they go, what? You have to say, you need to print the value in J, you need to print the letter J. When you talk about programming, you have to be really careful. If you just say print J to somebody, and you have a variable like J, do you mean print do you need the symbol J printed out, or do you need the value of the variable named J printed out? Okay, so here, before I was printing the symbol star, before I had it the symbol star, and then I said, oh, I need to print J, and I made the mistake of just changing the symbol to J. Okay, so I need the variable J. Okay, right, visualize it. Okay, there's that pattern. Okay, what if I change the parameter, make it go up to 9? Does it still work? Does it look right if I go up to 9? Okay, there it goes up to 9. Notice I've got ones on that diagonal, and I'm counting down I'm counting up from 1 till I hit this edge. Okay, okay, and and then you can do all kinds of funny patterns. Like, for example, what if I didn't stop this counting up to be? What if I, instead of when I count up, what if I just counted up to rows instead of, what would it look like? Just don't, like, count from 1 to rows all the time. Okay, you get that pattern. Okay, before we were chopping this thing off there. See, before we chop that off, but now everyone goes up, so you get this kind of skewed box. Okay, you can get all kinds of different patterns these ways. Okay, that was what we had. Okay, and that chopped off each row on the right edge. So that chopped off each row on the right edge, and so instead of it going on, all the rows got chopped off there, and you get a triangle. Okay, okay, so let's do another pattern. Now here if you notice, we've kind of done all 4 possible patterns with this kind of triangle shape. Let's see, start here. triangle that's shrinking, but with the spaces on the right. Triangle that's shrinking with the spaces on the left. Triangle, let's see, triangle that's growing with the spaces on the left. And then, oh, did we do the growing triangle with the space? Yeah, I guess we didn't do all possible ones. Let's see oh yeah, here's growing with spaces on the right. Okay, so the triangle's growing, the triangle's shrinking. Okay, but two different, yeah. Here it grows from 1 to 6. Here it shrinks from length 6 to 1, but the spaces are on the right. Okay, so the spaces don't really matter to us. We don't need to print out the trailing spaces. And then we did here with the spaces. Here it's the triangle part's getting bigger with the spaces on the left, and here the triangle part's getting smaller with the spaces on the left. So we've essentially done 4 versions of this. We've printed a triangle 4 ways. Okay, if you think you can take that triangle and flip it over 4 different ways. Okay, so that's about it you can do with triangles. Um, if and then you could also vary from counting up to counting down. Okay, so like here we counted up to 6 all the time. Here we counted up from 1 all the time. So it's like, notice it didn't change the shape of the triangle, but it changed what numbers we put into it. So there's little variations. There's 4 possible shapes, and then you could do little variations on where you start with what you start with. Now this leads to a lot of puzzles. You can give people challenging little puzzles by changing all these little shapes and changing like where the number starts with. So you can create lots of example problems, and they're really good problems. This is a kind of these problems lead you to think in a way that's really useful for programming, because what you're trying to do is recognize patterns. Somebody draws this and says that's what the shape should look like if there's 6 rows. Yeah, and you have to think, okay, what does the shape look like when there's 7, 8, 9 rows, and then how do you encode it in the program? Okay, now here's a file I wrote with a bunch of different patterns in it. Like we've already done a few. See, here's the 1, 2, 3, 4 ways of doing a triangle. Okay, now here it's without the numbers. Here's just the like we've already done. Like this one here would be that pattern there. See, that one's that one, but with stars instead of numbers. Okay, and then this one is that one. See, with stars. Okay, and then this one here was the next one. That's this one. Okay, and the last one we did is this one. Okay, now let's try this. What about this one? Here's some variations. I could ask, like do this or this, or how about make this a pattern? Actually this is meant to be 2 different patterns. One that the triangle, you have this kind of like triangle that's just shrinking from both the left and the right. See, the idea is you start with this row, and then it shrinks by 2. It shrinks by 1 item on the left and 1 on the right. Then it shrinks by 1 on the right and by 1 on the left, and then there's nothing left. Okay, so make this pattern of instead of being a triangle with like here, instead of shrinking by 1 on the right, shrinking by 1 on the right, shrinking by 1 on the right, you want to shrink by 1 on both the left and the right. So start with that 6 in a row, but then shrink by 1 on either end, shrink by 1 on either end. Okay, so you create a more like an isosceles triangle. Okay, or how about creating boxes? A box with a diagonal in it. Okay, so let's try, for example, do this one. Okay, so what I'll do now, this one, let's try this one. This one kind of looks like that one. Okay, notice it is, it's got spaces over here, And so it kind of looks like that one. So let's go over to the code that did that one. Let's see, where was that one? Okay, that's this one. Okay, so I'm going to copy and paste this one. Okay, but I want to change it to be, I want to do this pattern here. So I want it to be that pattern there. Okay, so below is what the code now does this. The code does this, and I want to change it to do this. I shouldn't have to make too many changes, but I want to think about what kind of so there's some differences. The the numbers on the diagonal went 6, 5, 4, 3, 2, 1. Now the numbers on the diagonal go 1, 2, 3, 4, 5, 6. Okay, and there's just dots to the right of the so I put a number on the diagonal and then I put dots afterwards. Okay, now if I how much of this can I preserve? Yeah, the number of spaces is not changing. 5, 4, 3, 2, 1, 0 spaces. Okay, that part didn't change. Okay. Okay. Now nums it's just like what's the number? The number would be 1, and the number would be 2, 3. So there's just one number, 4, 5, and 6. And then there's the question of how many dots there are, how many periods there are, how many dots are there? Okay, well, there are 0 dots in that row. There's 1 in that row, 2 in that row, 3 in that row, 4 in that row, 5 in that row. Okay, now here's what this is going to be. There's going to be a for loop to do spaces. We'll print this number by itself in a print line, and then we'll need a for loop to print dots. So now the spaces isn't changing. So this part that did spaces, we should be able to leave it alone. Okay. And then in between here, we print the one number. It's a print, not a print line, because it's in the middle of the line. But then I have to decide, what do I print here? Okay, so I'm going to print the spaces. They don't change from this pattern here. Okay, but then I print one number by itself. Now the number, well, then I have to decide which kind of row pattern am I using. Let's stick with, we've been using the pattern of 1, 2, row 1, row 2, row 3, row 4, row 5, and row 6. Now we've been using that pattern. You can do the pattern where you start with row 0. We've been sticking pretty much with the starting with row 1. Notice that then the number I print is exactly the row number. So in row 1, I print the number 1. In row 2, I print the number 2. So here I'm printing the number in I. Okay. All right. And then, okay, now here I'm going to print dots. And the number of dots is 1 less than the number of numbers I did over here. Okay, now notice that over here I printed 2 numbers. Okay, but now I want to print 1 dot. So I want this loop to do 1 less iteration. I can get that by doing rows minus I here. Okay, let's check. Okay, how many dots are there? Okay, there's 0 dots here. Okay, I is 1. Let's see. Oh, okay, let me change this. Where do we start for the dot? Let's do this is now do the dots. Okay, do the spaces, print the number. It's in the middle. Now do the dots. Okay, we need to know how many dots to print out. Okay, well, the number of dots is here. 0 dots, 1 dot, 2 dot, 3 dot, 4 dot, 5 dot. Notice that that's always the number of dots is one less than the row we're in. So in row 1, 1 dot. In row 2, in row 1, 0 dots. In row 2, 1 dot. In row 3, 2 dots. So it's the number of dots is one less than the row we're in. So we can count up from 1 up to, what row are we in? I, one less than the row we're in. Okay, so we'll count up from 1 up to one less than the row we're in. That's how many dots there are. We count how many dots there are. It's the number. I'm sorry. So I keep getting mixed up by going to. We don't want that table anymore. The number of dots is one less than the row we're in. Okay, so this is counting from 1 up to one less than the row we're in. One less than the row we're in. Okay, let's check. Let's see if that prints this. Oh, let's see. What did I do wrong? I had left this thing as 1, so I want to do it with 6 rows. Okay. Okay, there's the output I wanted. Okay, let's see. What does it look like if I do 9? You know, if I do 9 here. Okay. Oh, sorry. Now, if I can't do a 10, because if I do a number larger than 9, it'll goof up. Like if I do 15 here, it'll because it's when I hit 2-digit numbers, it screws up what's on the diagonal. See, it kind of messes up what's on the diagonal. Though I can fix that if I want to do bigger patterns. I could just not put a number on the diagonal. I could put some symbol on the diagonal, like I'll put a pound sign on the diagonal. Okay, and let's see. Now it's not going to work because the visualizer really restricts how many loops you can make here. Okay, almost finished. It almost got to the end. But if I put this in the Java visualizer, I can do as large by not using a number on the main diagonal. If I put a symbol on the main diagonal, then I can make the pattern as big as I want. Okay, all right. Right. Now let's see. We had a number there. Whoops. Yeah. Okay. Okay. Now what we'll do, there's more see, now we did, now you can, this pattern came out of that triangle. Then you can, but then this triangle, you could play around with it and get this pattern. Okay, slightly. So you could start with the code for this. We did this one already, and make a little change in it, and it can become that pattern. Okay, and then on next week on Monday or on Tuesday, we'll do some of these other patterns because they actually do. They can get trickier. And there's I have more of these patterns. I'll put them up on the website so you can see them. And we'll just do, we've done these a couple different ways. We did these with both stars and with numbers. And then we did this one. And like how can we do a square? And then what's interesting is like do a square, but then fill it in partly. Like what if you do the square, but put in that diagonal there, or you can do that diagonal there. Okay. And you might ask, isn't this kind of a silly way to spend my time? And the answer is partly, you're not drawing useful pictures, but one, the style of thinking this involves with is really useful. There's plenty of problems in computer science that are very much like this. And then actually drawing geometric shapes isn't unusual. Think about games. Somebody has got all the geometric shapes you see in games, even if you see, like here, this is meant to be a checkerboard. Okay, think of how many times you see some kind of checkerboard pattern in a game. And that's you have to, somebody's got to program it. you can't just take a picture of things and then, you can say, well, just take a picture of a checkerboard. Well, that doesn't work. A lot of times you need program to generate a checkerboard. So here's a checkerboard pattern that's been generated by code, and it's painting it using ASCII characters instead of colors. But yeah, it wouldn't be much to change that to print colors in a graphics program. Okay, and you can do hexagonal tiling. This is a square tiling. Then there's hexagonal tiling. So there's, somebody has to write all the code that generates those geometric shapes. So you end up having to think very much like these things. You end up thinking a lot like this. Lots of programs print out shapes and patterns. Okay, so now I'll put up on the website uh, a couple. I'll put up on the website a bunch of examples of patterns that you can look at if you want to over the weekend. So I'll put up I have a lot more of these patterns, and we'll do some more of them on Tuesday, and then we'll start the next part of the course. So we'll go on to but we're going to go back to writing methods. So we're going to go back and do more with writing methods in a little while. And then we'll go to arrays, and then we'll go to classes. That's the next couple of topics in the course. Okay, so on Tuesday, we'll do more patterns, more nested for loops. We'll keep doing trickier and trickier ones. They will get harder and harder. The goal is to make these patterns get trickier and trickier. Okay, so we run out of time. Anybody got any questions before we quit? Remember to look at your exam. Yeah, and look at the exam. I keep pointing out, don't just look at your score, look at your exam and to look at how you did in each problem, look at what I wrote about the problems, and ask questions like, how is something supposed to have been done? A question about any comment I make. Okay, so we'll quit there. Have a nice weekend and see you next Tuesday. Bye.